Hi, good morning everyone, and welcome to our artifact review. My name's Ian Taylor, and I'm part of Project 34, and we are creating a project for the sizing company Edge-Based CV, and we are currently in our sprint number 1, and I'm just going to give you a bit of an overview. This is our burn down chart in view here, currently located on the 25th here at this point, and you can see that we are on schedule. We were a bit slow in the middle, and that was a bit of holdbacks due to our investigations, which took longer than expected, with a lot of us being new to Python, AI, and image processing. Just to run through, so for this actual sprint, our main goal was to implement minimum viable products for the first 4 modules, which are our distance estimation, pose estimation, brightness correction, and multiple person detection. And these are actually 4 of our deliverables, and we're just actually getting a bit of investigation on the best ways to approach these and coming up almost with a type of like prototype of implementing these. So just to run to the first one here, where you have a Python model that checks if multiple people are in a given image, and I'll just switch over to the tab here. And during the process of coming up with this, there were found to be 2 methods of it, and one of the methods, approach 1, in order to count the amount of people in the image, they used HOG, SVM, and OpenCV. And there were a bit of problems with this. A common issue detection was like a image down here, and it's, as you can see, it's detecting 5 people when there's actually only 1 person in the image. And for this reason, we have decided to go with OpenPose to detect the person and use this to find key points and return a JSON key point set. And then this will represent 1 person, and due to inaccurate detection from the approach 1, open source person detection will be used. I'll just pause the video while I get to that code. Now just continuing, bringing up the code here, and this was actually for the option 1, which was the focus, and this was using CV2 and a few other libraries without AI. And this was the code that came up, this Python file, and this NMS Python file was actually to avoid those box issues that were coming up, these ones. And as I said, it worked, but we are going to try and improve on that, as I said, with the open source. Moving on, next we then moved on to having a look at basically getting an image for this deliverable was to deal with getting images to check the brightness and the contrast on an image and see if we could actually handle getting the dimensions of the person from this. So I'll just switch over to here, and it was all to do with using a manual algorithmic approach, and the first one was to find a bright area, and a problem found with this bright spot was that it might just be 1 bright pixel. So we then came up with a way of finding the average of a certain area, and we used CV2 to read in the image, apply a gray filter, apply a Gaussian blur and that actually cancels out a lot of the noise by applying that blur. And then if there is a bright spot, which was we decided on 240 being high, a value for a high spot, and if this is found, the calculation is done on that spot. And if it's above 225, the image will be shown with a circle around it, and I'll also run through an example of this. Then with the contrast checker, there are 2 different methods for this approach. Both work well. It's basically just checking the difference between the contrasts and making sure that we will be able to work with that. It's just a bit explaining the actual ways, and then we combine these two functions into one file, and this is going to be like a possible prototype for deliverable 2, although we will investigate further for AI approaches, and then there's a bit of a test for this. So I'm just going to pause the video while I go to the code. Okay, continuing with our artifact review here, I'm just going to run the code. This is for the average pixel size of a bright area, and basically, as I spoke a bit about it before, but as you can see here in the image down at the bottom, it's found a bright spot, it's circled it, and it's also taken the average pixels, brightness of those pixels of that area, and if it's above a certain threshold, we are then going to display a message or basically reject the photo. Just running through the contrast here, pretty simply, there's two methods here. So the one method uses this library, and which has a built-in function which is called isLowContrast. Very simply just checks if the contrast, whether it's too low for us to work with. And then the method 2, we use more statistical means of the image, and then that tells us whether it's low. If it's below 100, then we know it's a low contrast. Now I'm just going to pause the video while we move on to one of the other deliverables. Just continuing with our artifact review, and another deliverable that we were working on, getting a module for it, was to check that the pose position of the users in the image is sufficient for us to get the measurements. And with this, some of the tasks were to pre-train pose estimation implementation and download a repository, create plot function to see the body vectors, overlay the inside of the Jupyter notebook, get the key points of the body into the dictionary and lower the overhead, label key points, and run in a development environment. And to obviously get this demo to run, I'll just move over to the actual code here. I'm not going to run it due to this being quite a large file system that's built on another user of our project's computer and not actually mine. This is the code here, and as you can see, it uses OpenPose, comes in and does a lot of functionality on the images. It's getting good results. We are still working on the actual process. And as you can see in this notebook, there is a lot of code here handling this sort of area, and we are pretty happy with it. We've got a description of how to run it here. And I will now pause as we move on to the next one. Continuing with our artifact review, and we had another user story of that checking the distance of the pose in the figure, and this was we decided to go with an AI approach, pre-trained model, and it was basically create a notebook that can read in an image, generate basic bounding boxes around a user's body, and integrate pose estimation module to generate a body landmarks. And the main goal was just ensuring that the whole body is within the frame and at a suitable distance for the data to be collected. The possible methods, we can create a pose estimation model to place a landmark on the key body parts, and this landmark can then be used to check for various conditions, including whether the landmarks goes out the frame's edge and critically close to a frame's edge, and determine if the body's boxing is within acceptable minimal pixel area range. Just going to pause while I go to the code. So continuing back, I have now pulled up the code for this distance estimation. You can see here this notebook expects to find open pose and test images per the tree below. We run through here, and as you can see with this picture, which is a good picture provided by our client, and you can see here it's marked the person in the image perfectly. We can see that none of the image parts are critically close to the edge, and we can actually get good dimensions off this image. This completes our artifact review, and just to run through it, we are on track. We're happy with our progress. We've got a bit of feedback from the client, and we're working together with the teams, and they are actually giving us a bit of help, providing us areas that we're missing. One of the advice they gave us was to use open pose, and we're going to continue progressing the way we are and are happy with our progress. Thank you for watching this artifact review.